Okay, good afternoon to all. Am I audible clearly? Somebody can reply. Asmita, thank you. So, last lecture, I think we have started steam condensers. So, steam condensers definition, purpose of steam condenser that we have revised yesterday. And again, we have completed some here advantages of condenser, functions of condenser, then here elements of steam condensing plants, then elements of steam condensing plants wherever there is less water is available, then this kind of cooling tower arrangement we are making. And if it is not there, then if amount of water for cooling purpose is available in abundant amount, then we are using we are cooling tower we are neglecting, and only whatever the water we are using from river, we are not reusing that water. But whenever we are when less amount of water is available, then here in that case we are using the cooling towers. So cooling tower purpose is to cool the water. Whatever water is going to be become hot uh, after giving its after absorbing heat from the steam during the condensation process, and that water is going to be cooled while using cooling tower with the help of air. So this I think we have completed. So now we have started just the classification of condenser. So I request somebody can reply. What is meant by there are two types of condensers. One is jet condensers, or it's called as direct type of condenser, or it is called as mixing type. And another type of condenser is called as surface condenser, or it is also called as non-mixing type of condenser. Okay, or it is indirect type of condenser. So I want some definition from some of you. What is meant by jet condensers? Jet condenser means what? Anybody of you? I want to reply. Maybe by mixing of exhaust steam and cooling water. Okay, Asmita is correct. So the condenser in which there is mixing of exhaust steam and cooling water takes place. So that type of condenser is called as jet type of condenser. And another type of condenser. So this with these basics, we are going to learn different types of condenser. So first type of jet condenser is parallel flow type condenser, low level, and counter flow. So and another is ejector type. So these are the three types of jet condenser. One is parallel flow, then another is counter flow jet condenser, and another third one is ejector type of jet condenser. So jet means always remember that it is mixing of exhaust steam and the cooling water. And another type of condenser is called as what? Central surface condenser, or non-mixing type of condenser. What is mean by this surface condenser or non-mixing type? Anybody of you? So heat transfer is necessary for the heat exchange, heat transfer case. But what is meant by surface condenser? Anybody of you? Surface condensers, or it's also called as non-mixing type of condenser. Anybody of you? Can be chat box if you want to reply, or you can unmute yourself and talk. That option is also ready. Somebody, Asmita, given last option very correctly about mixed jet condenser. So it is somebody other than Asmita. I'll be happy because she only answering, or Asmita I can also answer. Okay. So nobody. Surface type of condenser means what? It is heat exchange is taking place, but what happens? There is no direct contact between the cooling water and the exhaust steam. So exhaust steam and cooling water doesn't mix with each other, but only heat transfer will take place. So that type of condensers are called as surface condenser. So There are different types of surface condenser. That is down flow, one is center flow, inverted type, regenerative, and evaporative type of surface condenser. So all these three, 5 to 8 condensers we have to study today. Then this is the schematic representation of jet condenser and surface condenser. So this is here jet condenser, everybody know. So jet condenser means here it is here only one vessel is there, closed vessel, in which cooling water is entering into this condenser from one side. Exhaust stream is also entering through this device here from one direction. Okay, and here cooling water and exhaust steam, and they are get mixed with each other. Then cooling water will take the heat from the exhaust steam, and the exhaust steam will also be converted into condensate, that is liquid water, and there is mixture. The total mixture will be there. Mixture is consisting of here your condensate. It is called as condensate. It is only mixture of this cooling water and this cooling water plus this exhaust steam. So exhaust condensed the steam. That is exhaust steam is get condensed. That will be the mixture. So if this cooling water is not pure, then this condensate will not be that much pure, and it cannot be reused directly into the boiler. So some chemical treatment we have to go for, water treatment we have to go for, so that to reduce its pH value, to remove the some salt solutions from that particular condensate. Because if the salt will be carried out in the boiler, definitely there will be corrosion, erosion, and that tubes of boiler will get eroded. Then here another type of condenser is surface condenser, and surface condenser in which there is not indirect contact type, there is no direct contact. So if the cooling water will take flowing in the form of in the tubes, flowing in the form of tubes, and exhaust steam is flowing around them. So exhaust steam is flowing here from top here, and it will be flowing in the downward direction, and around them here on this particular cooling water. So cooling water is taking inside these tubes. Okay, so this will be taking place. Okay, and it will get heated after here absorbing it from the exhaust steam, and here it will be here the cooling water will be again resuscitated to cooling tower, and this condenser is pure because it is not mixed with any of the cooling water. Therefore this condenser is very pure, and without any treatment we can use into the boiler because it doesn't contain any salt solution. Purity is much more. So this is also we have completed yesterday. It is a comparison. So the main time they are going to ask the comparison between jet condensers and surface condensers. So cooling water, we as earlier, cooling water and steam are mixed up. Okay, this is a closed vessel in which uh, cooling water and exhaust steam are get mixed with each other. And in surface type of condenser, cooling water and exhaust steam aren't mixed with each other. So here cooling water will flow in the form of tubes, and around them steam will flow. As it is very simple in construction, only there is one vessel is required where mixing is takes place. So therefore, jet condenser having low manufacturing cost. As surface condenser, we have to go for the piping for water and surrounding them, so shell for the steam, and in through that piping we have to go for. So little bit complication, and complications are complicated geometry as compared to our jet condenser. Therefore, manufacturing cost is high. So requires small space because here small floor space, because efficiency is much more because they are directly mixing with water. But here it requires efficiency less, therefore requires larger floor space. Condensate cannot be used as feed water in jet type of condenser unless it is free from impurities. And if impurities are there, we have to go for water treatment. And here surface condenser, the condensate can be used to feed water boiler directly because it doesn't mix with cooling water. Then as air, more air, because here there is direct contact, so with the help with the exhaust steam as well as with the water, cooling water, the steam will enter into this particular condenser, and therefore more power is required for the air pump. So because if you want to maintain the vacuum inside the condenser, so in that case more power is required for air pump. Here less power is required for the air pump. But water pump, as water is going to be only, here it is mixing with the steam, therefore less power is required for water pump, and here more power is required for water pump because this water we have to circulate through the tubes, and therefore pressure difference is much more, and more power is required for this. So require less quantity of cooling water because efficiency is much more. There is no loss directly. Water is get mixed with the steam, and therefore requires less quantity of cooling water. Requires large quantity of cooling water because it is here here indirect type contact. Efficiency as compared to jet, it will be less. So the condensing plant is simple. Only special we have to go for. The condensing plant is complicated, little bit complicated as compared to jet condenser. Then less suitable for high capacity plants due to low vacuum efficiency. Low vacuum efficiency means entering air is much more. Source of air leakage will be much more, as and here more suitable for high capacity plants and vacuum efficiency high. So lower upkeep is required. Just काळजी घ्यावं लागत नाही. Higher upkeep is required because manufacturing is somewhat more difficult, and we have to maintain vacuum clearly. Now, up till now, I think anybody having problems, please mention. So jet condensers are used in small capacity units where clean fresh water is available in plenty amount. So Asmira Sarvadi replying, no problem. So others also I request to reply. So jet condensers are used in small capacity where clean fresh water is available in plenty of amount. And in jet condenser, water is direct contact with exhaust steam, hence these are also called as direct contact or mixer type. So I already explained this here on my side. Then advantages and disadvantages of jet condensers. What are the advantages of jet condensers? So as a result of effective mixing, it requires less circulating water because there is a direct contact between the exhaust steam and circulating cooling water. Therefore, less cooling water efficiency will be much more. And as surface condenser, there is indirect contact is there. So therefore, less amount of water, less efficiency, heat transfer efficiency is there. So equipment is very simple. This is a jet condenser equipment is simple and occupy less space. Maintenance is cheap because low manufacturing cost. Disadvantages not suitable for high capacity plants. Condensate cannot be used directly as a feed water. Then air leakages are more, require larger air pump and less vacuum maintained. So these are very disadvantages. So whatever the comparison points are, there some negative points we call it as a disadvantages, and some positive points we call it as a advantages. So affecting mixing, less water is required, less size of cooling water pump is required. Equipment is simple, manufacturing is simple, manufacturing cost is simple, maintenance is cheap, but not suitable for higher capacities. Air leakage is more. Okay, requires larger air pump, less vacuum is required, and as cooling water is not that much pure, therefore this condensate is mixture of cooling water and exhaust steam. Therefore, cannot be used directly as a feed water to the boiler. We have to make water treatment. Then surface condenser highlighting points. Surface condensers are used in high capacity plants. Okay, because vacuum efficiency is much more. And here cooling water directly we can condenser directly we can use it to the boiler because it doesn't mix with cooling water. Therefore, and that condensate, whatever condensate we are obtaining from surface condenser is very, very pure, and therefore it directly can be used into the boiler. In surface condenser, exhaust steam and water do not mix with each other, therefore they are called as indirect type of surface condenser. This point also I have told many times to you. Then advantages can be used for large capacity plants, High vacuum can be created because less loss air entering, because there is only through the pipes cooling water is flowing, and through the exhaust steam is entering around that. Therefore, there is less leakage of air, and therefore high vacuum. Less leakage of air means less amount of air is present inside the condenser. Therefore, high vacuum can be created. Then condensate is free from impurities because it doesn't mix with cooling water, and therefore it is pure form, and it can be used. Condensate is free from impurities and can be used, reused as if you were to boiler without any water treatment. Then impure water can also be used as a cooling medium. So impure water can also be used as a cooling medium. Air leakage is comparatively less, hence less power of air pump is required, but water pump is required in much more size, because water we have to circulate, we have to force the water through the tubes, and so that it will get mixed with steam. Heat exchange will take place immediately. Okay, so design is complicated, high maintenance costs. These are the disadvantages. Design is complicated, high maintenance cost, occupies more space because efficiency is less, and requires more circulating water because there is indirect contact in between cooling water and the exhaust. Okay, now before going for this condenser types here in detail, anybody having doubt about this, please mention. If understand up till now everything understood, understandable, doubt, repetition is required, please maintain. We are going very slowly. Our syllabus is not, no, there is not much more problem for no doubt, sir. Understood. Asmita only answering, chatting. Others, please reply. Please mention in your chat box if you don't like to start your mic. Prerna and Asmita only, they are interacting. Prerna understood. Others, please reply from voice side. Anybody? So today we are going to discuss about details about the parallel flow type jet condenser. Before that, I want some reply from your side so that I will get little bit confidence that okay, whatever I am teaching you, you are understanding. This is not the offline teaching, under online teaching. I don't know what you are doing. Please reply. Others 23, 24 students are in the class, but still only 2 are replying, 2 are understanding. Others, please reply so that others I have to meet. Vishal, thank you, Vishal. Vishal met can understand. Okay. Okay, then parallel flow jet type of condenser. Now, here we have to remember that jet condenser means what? That condenser in which there is a direct mixing of cooling water and the exhaust steam. So that we have to remember. And here parallel flow means what? Now there are two streams. One stream is of what? Cooling water, and one stream is of what? Exhaust steam. If they flow in same direction, okay, so that type will be called as parallel flow. And low level. Low level means what? Whatever the cooling point is there, this cooling point and this condenser is having very low height, and that here much more height is not there. So this is a cooling tower. Here cooling pond is there. So exhaust steam and cooling water flow in the same direction. Now here, this is one jet condenser vessel is there. This is called a what, condenser vessel. So this is a condenser vessel. Okay. Now here exhaust steam is flowing in this direction, this top direction to bottom direction, up in downward direction. And we are taking the cold water maybe from this cooling tower, cooling pond or river. Okay, and this water we are taking, and this height is very less. So therefore, as this is vacuum is there, so this vacuum will here draw this water inside this particular condenser. So this, due to vacuum, this cold water will get inside this cold water, and through the nozzles, there are spraying nozzles are there, because and this water is going to be sprayed into this particular condenser. Because of this spraying in the nozzles, what happens? The water is formed in smaller droplets. As it is becoming smaller droplets, the heat transfer area that is available, natural area available for the heat transfer will become more. म्हणजे जर एकच ड्रॉप मोठा टाकण्याच्या जर आपण बारीक बारीक ड्रॉप केले तर काय होईल? The area, exposed area will be become more, and therefore we are sprinkling the water, spraying the water in the form of nozzles, and we want to make it as a breaking jet. Okay, and this steam will here in become in contact with this water, exchange of it will take place. Baffle plate is there, so where exchange to make the proper exchange, and whatever the air is there entered in the with the help of this exhaust steam, and the cold water is removed from this air pump. So here, due to that, whatever the mix vacuum is there, maintained vacuum is remain, or we can maintain vacuum, desired vacuum inside the condenser by removing the air. The cold water is sprayed exhaustive, and this condensate is there inside the condenser. As there is a vacuum, and outside there is a atmospheric pressure. So here low pressure and here high pressure. So there is difficult to take this particular condensate from low pressure to high pressure. Therefore, here one condensate extraction pump is required. So this condensate extraction pump is there. The low level condensate extraction pump is there. So this condensate extraction pump is here take the condensate, force the condensate to come out and collected in the hot well. So hot well means where we store the hot water, hot condensation, and this afterwards we are supplying to the boiler. Okay, so this is condensate after, but it will not come directly because pressure mentioned inside the condenser is low vacuum. So vacuum to atmosphere, it will not come directly. Therefore, condensate extraction pump is required. This condensate extraction pump, hot well will store the hot condensate, and after when required, it can be refeeded or used to the boiler. And if overflow is there, if more quantity is there, it is again supplied to the cooling pump. It will get cooled automatically. Now this is called as parallel flow low level jet condenser. So this height is also less, and here condenser extraction pump is required, and steam is also flowing in the downward direction, and cold water is also flowing in the downward direction. So that's why this type of condenser is called as parallel flow type of jet condenser. So mixing twist take place here. Understand? Any doubt? Why it is called as parallel? There is mixing, therefore there is only one stream of cold water and one stream of exhaust steam. Condensate extraction pump, because here inside the condenser, your vacuum is there. Please reply. Understood, sir. So if I will give 2 minutes to you, maybe okay. Let you take 3-4 minutes and complete diagram. At least some components. line diagram you can go for. Don't go in that much line diagram you can go for, and tell me over. Within less time you have to draw this. So parallel flow means the steam, exhaust steam and cooling water both are flowing in the same direction. So that type of condenser is called as parallel flow low level jet condenser. Asmita, or others, please reply. Okay. So another type of condenser is also same, but it is counter flow low level jet condenser. Now counter flow, why it is called as counter flow? Because now here, what you here, so everything is same. So here hot well is there, okay. Here cooling pond is there, or river is there, overflow pipe is there, okay. Condenser suction pump is there. Only thing is in this condenser vessel. What is thing is there? Anybody can differentiate? Or anybody of you? I am going to explain you, but still, what is counter flow means what? Anybody of you? Counter flow means anybody of you? How we can define counter flow? So steam, exhaust steam is in one flowing in upward direction here, and cooling water is flowing in the downward direction. This is called as counter flow, opposite direction. Both, this is the exhaust steam, you can say exhaust steam is flowing in the upward direction and cooling water is flowing in the downward direction. And here, okay, and so this, sorry, cooling water is flowing in the downward direction. So here direction. So exhaust is flowing in upward direction, cooling water is flowing in downward. Both are flowing in the opposite direction. And in this case, more area, more time, water and exhaust steam are, when their interaction is much more time, much more happens as compared to parallel flow jet condenser. So here in the condenser, everything is same. So from the cooling pond, cooling water is going to be fetched through the vacuum with the help of vacuum inside the condenser. Okay, so there are spraying jets are there, where nozzles are there. The nozzles will break the water particles into minute particles. Okay, and here this water will flow in the downward direction. At the same time, this exhaust steam will flow in the upward direction. It is from entering from the bottom and going into the upward direction. And during this, here baffles are provided. So during this here mixing will take place, and after mixing, density of condenser will become more and it is stored at the condenser at the bottom side, and it is removed with the help of extraction pump. It is called as condensate extraction pump, and it is stored into the hot well. Okay, from the hot well, this is reused to the supplied to the boiler, and overflow is given to the cooling pond where it is cooled water cooling pump, and afterwards this is reused once again. So this is called as what? Counter flow low level type of jet condenser. Only thing is there, and air pump is used in the upward direction. So where it is removed air is coming with the help of entering due to entrance of exhaust steam and the cooling water. So this is only change is there in the low level parallel flow and counter flow. The steam is entering into upward direction and cooling water is entering into the downward direction as usual. And air removing pump is at the top. Anybody having problem in understanding? Please reply. Only Asmita and Prerna they are replying. Others please reply. Asmita, we understood, sir. Okay. Very nice. Prerna, Vishal Mitkari, sometimes replying, sometimes not replying. Others, please reply. Prerna, okay. Others, please reply. And draw diagram. I will give once again 5 minutes to you to draw the diagram. Others please reply. Asmita server is also diagrammed over. Okay, so we'll go to the next type. It is called as what? High level jet condenser. Okay, and it is called as counterflow. Counterflow means what? Counterflow means here we have to identify the counterflow means here steam is flowing in the four direction. Steam is flowing in the four direction and cooling water is flowing in the downward direction. Therefore, it is called as what? Counterflow. Now, why it is called as high level jet condenser? Because here, whatever this condenser vessel, this is condenser vessel and this hot well. So this pipe is having height 10.363 meter. So it 1 atmospheric pressure, if you consider in case of the mercury column, it will be 76. 1 atmospheric pressure is equal to 0.76 meter of Hg. Okay, but if we want this pressure in terms of water column, then water is having less density than the mercury. Therefore, 1 atmospheric pressure and mercury is 13.6 times greater than its density is greater than water. Therefore, 1 atmosphere is equal to 30. If you multiply this by 13.6, and we'll get answer as a 10.63 meter of water column. Of what? This basically important, therefore I'm giving much more stress. Okay, so therefore if here it is vacuum, but here if we maintain this column of 10.63 meter height, then what will happen? This condensate, while it coming into this particular pipe, its pressure is goes on increasing, and at this point where it will become height, at this much height, lower height, 10.63 meter. So this pressure will become atmospheric pressure. And therefore, this condensate, after maintaining this much height, 10.63 meter height in this vessel and this our hot well, what happens here? Here, there is no need of condensate extraction. This condensate will naturally come into the hot well. But we have to maintain the height of this hot well level of water in hot well and their condenser vessel up to 10.63 meter. Then this naturally this condensate will fall into this particular hot well. And but as 10.363 meter means in case of the feet we can go for, it is near about 40 feet, means 4 multi-story building. One building is nearly having height 10 to 11 feet. So nearly about 10, near about 4 multi-storage building that much height will require in this particular condenser vessel and this hot well. Therefore, this is called as tailpipe. This pipe is very, very long, 10.63 meter, near about 40 feet. And but this now here, this cooling pond, from cooling pond, cooling water, we have to fetch up to height of 40 feet. And directly it will not come. So therefore, here one pump is required for cooling water pump. Here it is called the injection pump. Or this pump will take the water. It will help to take the water from this cooling pond to this vessel, condenser vessel. Okay, and for this pump is required. But in low level jet condenser, this pump was not required. And but here condensate extraction pump is required. Difference in between low level jet condenser and high level jet condenser is that due to much more tailpipe, condensate extraction pump is not needed here. But there low level condensate extraction pump is needed. But there injection cooling water pump is not required. But here cooling water pump is required because height is much more, and tailpipe here condensate extraction pump is not required. Other things are remaining same. And it is counter means steam is flowing in the upward direction and water is flowing in the downward direction. And this is what your air pump is there. This air pump is whatever the air is coming with the help of this cooling water and exhaust steam is removed with the help of this dry air pump or air pump. This is the construction of high level jet condenser. So again, I will explain. This is the height is much more in between hot well and this condenser vessel. It is nearly equal to, as 1 atmosphere is equal to 10.636 meter of water. Therefore, this height is 10.63. Due to this here, when water will come with the help of gravity, at this much height, then definitely pressure will become at the last 1 atmosphere, and water will this condensate will naturally come into the hot well. Therefore, condensate extraction is not required. Okay, then exhaust steam is flowing in the upward direction and water is flowing in the downward direction. Therefore, it is counter flow type of heat condenser. And cooling pond, and this much height is much more in between vessel and cooling pond. Therefore, cooling water pump or injection pump, it is also called as cooling water pump is required. Now, other things is there. Hot well, from hot well it can be taken to the boiler and overflow is given to the cooling pond. This is high level jet condenser. And air pump is used to remove the air entering into this particular condenser vessel. Understood? Anybody having questions, please ask. Asmita Sarvade understood, Prerna also understanding. Others, please reply, and I will give 5 minutes to you again. So draw diagram, complete it. Pipe is having height of 10.363 meter, because 1 atmosphere is equal to 10.363 meter of water. So tailpipe is too much high. Therefore, the condensate will naturally come down with the help of this tailpipe. There is no condensate extraction is required. But as the height of condenser vessel and this cooling pond is much more, therefore cooling water pump is required. Over, please mention. Over Prerna. Other students, I am always asking to report any problem, doubt. Now, here, if it is a parallel type of condenser would have been there. Here, exhaust steam will also flow in the downward direction, and here water will also flow in the same direction. But generally, what happens? Counterflow having more efficiency, because more time the exhaust steam and that water will get in contact with each other, and therefore proper mixing will proper heat exchange will take place in case of the counterflow. Therefore, generally, instead of parallel flow, counterflow heat exchangers are preferred. Now, one more type of jet condenser is called as what? Ejector type of jet condenser. So, ejector type of jet condenser. So, what is there in this case? So, it is here hollow truncated cones are used. So these truncated cones are there. This is having nature of convergent and divergent type. So what happens? This is a convergent. Okay, and at the end it is going to be divergent. So what happens when the cold water is entering? Sorry, it is divergent. Convergent means here area is goes on decreasing. This is convergent. This is sorry. This is divergent. Okay, so this is at inlet. The cold water is having much more area, and as area gets decreases, the velocity goes on increasing. So what happens? This cold water when it is entering, it is here. What happens? It is its velocity is goes on increasing. Okay, and due to that, what will happen? There is a proper mixing of this steam, because it's cold water with more velocity mixed with this particular exhaust steam, and it is coming in downward direction. And at this place, at the bottom side, what happens? There is a divergent cone is there. So divergent cone means what? Now here pressure will be vacuum. Pressure will be what? Vacuum pressure is there. And we want to increase the pressure. And to increase the pressure in dynamics, what we have to do is there, we have to increase the area available for the flow. And here, this mixing is having much more less area. So divergent cone is there. So area increases means pressure is increasing, but velocity goes on decreasing. But we are not caring about the velocity. If pressure is increased more than atmospheric, this condensate will die immediately. Naturally, it will come flow into to the hot well. So this here you maybe one hot well. Okay, this is only condensed vessel they have shown. So there is going to be cold water is entering through from the top. So exhaust steam is coming into the non-return wall. Non-return wall means you have learned in BME, sorry, drawing. Non-return wall means what? Anybody of you? Non-return wall. What is function of non-return wall? Anybody of you? Non-return wall allows that fluid or the steam in only one direction. So this direction, only in this direction the steam is allowed. Okay, so this steam is not allowed in another direction. This is the function of what? Non-return wall. So the steam will not return, will not come return back. So it will flow in this direction only. And truncated cone are there, hollow truncated cone. So this nature is having convergent truncated cone. Convergent means what? Here area is goes on decreasing towards outlet. So this is convergent truncated cone. Convergent hollow truncated cone. Due to what will happen, the velocity is goes on increasing here, and pressure is goes on decreasing. Pressure is decreasing, okay, and due to this high velocity, the steam is properly mixed with the cold water and it is get converted into condensate. So as velocity goes on increasing, here much more velocity is there, mixing will be proper, but pressure is less. And now we want to increase the pressure. And for that, instead of going for the convergent type cone, we are using diverging cone. So divergent cone means what? Area is goes on increasing here. Area is increasing means velocity will decrease, but pressure will increase and becomes more than atmospheric pressure. And our intention is what? Flow will always possible from higher pressure to lower pressure. Means here, this here when the pressure will be more inside, outside, then and then only the flow will come to here, come to this case. If pressure is become more here, and then only flow will naturally come to the hot water. So this is the one of the ejector type of condenser. There is no condensate extraction pump is required. Okay, cold water depending on the height, cooling water pump is required, but condensate extraction pump is not required. And this is the effective type of condenser. Anybody here understand? Please reply. Understood or repetition is required? Prerna Wankhede understood. Asmira Sarvade understood. Others please reply. And I will give 5 minutes to you to draw a diagram. over Asmita drawing over Prerna might be completing. This is about the jet condensers. Now here surface condensers. The surface condensers, now up till now in jet condenser we have seen that here there is direct mixing in between the cooling water and that exhaust steam. And whatever the condensate is mixture of that exhaust condensate of exhaust steam and cooling water, and it is get stored at the bottom side. If it is high level jet condenser, tailpipe were increasing of height 10.36 meter, and then pressure will be becoming more than atmospheric, and water condensate can driven naturally to the hot well. And if there is less height, okay, low level jet type of condenser, here condensed extraction pump is required. And ejector type, here the convergent and divergent cones we are using to increase and decrease the pressure. Okay, initially we want to decrease the pressure and increase the velocity for proper mixing, and at the end we are using divergent cones so that pressure at the end will become more. Okay, but there is direct mixing. But now in surface condenser there is no direct mixing in between the cooling water and the here exhaust steam. So there is like, this is a one kind of shell. So this is water, this is going to be one kind of boiler. You've seen the boiler like construction. So this is like a shell type of construction there. Shell means covers, and in that case shell we're using this particular water tubes are used. Okay, so this is going to be here one kind of this kind of shell outside structure. Okay, is used. Okay, this is shell, and in this shell there is one plate. This is going to be baffle plates are there to support this. Okay, and to supporting this is going to be one of the supporting plates, and a pipe is there. So, and these are the water tubes. So these water tubes are there. So what happens? Water is entering into this particular, in this case is entering into this side. Okay, so it is entering into this side, entering, and here it is removing, we are coming from this side. So this water is entering to this side. Here it is blades are there, and this is coming into here, entering, leaving to this zone. Okay, now while an exhaust steam is flowing from the top direction, so this is going to be exhaust steam from the turbine is flowing in the direction. Now water is flowing in this direction. Okay, now when steam comes in contact with this particular water inside this, here it will get start condensing. This hot water, some less amount of it is going to be taken from this water. Okay, and at that last, this water is very cold, much cold, and this steam will get condensed fast, and this condensate is removed with the help of this air pump. So because that naturally it will, with the help of gravity, condensate to extraction pump, or depending on some nature, if the hot well is too much having less height than this condenser, naturally it can be driven to the hot well. Or sometimes if we want more flow, in condensate extraction pumps are used. Okay, so exhaust steam is flowing in this direction. This is surrounding to this particular tubes. This exhaust steam will flow. It comes, heat transfer will take place in between the inside water, inside the tubes. Okay, tubes and exhaust steam, and the water will absorb the heat from the exhaust steam and get steam start condensing, and at the bottom it will completely condense, and this condensate is driven with the help of condensate extraction pump. Okay, and this water is entering in at the bottom side, leaving at the top side. This is a hot water. This is backflow plate for supporting purpose. So so that this hot water, inlet water and outlet water should not get mixed with each other. And this is the plates. This is called a shell and tube type of condenser, or it is called a what? Downflow type of surface condenser. Downflow means what? Steam is flowing in the downward direction from top to bottom, down direction. Therefore, it is called downflow, or it is also called as another name is there. It is going to be there. It is going to be shell and tube type of condenser. Shell means entire facility shell, and tubes, water tubes are a shell and tube type of condenser. Here, water is hot water is living in through this tube also one end, and cooling water is entering at the one end. There is no mixing of hot water and the water and steam. But here, in with the help of heat transfer only, the heat exchange will take place, and water is get condensed. The steam is get condensed at the bottom and removed with the help of condenser extract. So drawing is very difficult to draw, but understanding is simple. Am I right? Understood? Understood, please mention. Only there is no direct mixing. Here we have to remember that there is no direct mixing. Understood, Asmita, Prerna, Vishal Metkari, others, Avtade, Jagannath Avtade, Pawan Shinde, not replying. I don't know why they are not replying. Vishal, no reply, understand. Now draw diagram. I will give again 5 minutes to you. Steam is flowing downflow because steam is flowing in the downward direction. Over. अस्मितावर प्रेरणा might be completed. Now here central flow. Central flow means same kind of heat exchange condenser. Only thing is there that instead of here steam is flowing in downward direction, it will flow in the radial direction. So from all our periphery, the steam is flowing from the periphery, all directions here, and the air extraction pump is taken at the center, and here exhaust stream is flowing in this direction, and through this baffles, through this here pipeline, the water is flowing. So this is going to be the pipeline. Pipes are there, water pipes here. Through this here, the steam is flowing in the downward direction and water is flowing in this direction. Okay, radial direction. Steam is flowing in the radial direction. Therefore, it is called as central flow. Okay, in toward the center, and water is flowing through this zigzag kind of tubes. So again, mixing will take place, and here air is removed from this air extraction pump. Whatever it is coming with the help of exhaust steam, okay, and this air is removed from the center, and this condenser, this is afterwards, this is get mixed with the pipe water tubes, water through the tubes, the water is get heated and it will get removed from here, maybe water a outlet pump, and here this condenser is here at gravity, it will fall into this particular bottom area, and with the help of this condenser extraction pump, it is get removed. So it is called a central flow surface condenser. So steam is flowing in the central direction, and therefore as centrally it is flowing, so air is removed, only air is entering in through only this particular maximally through this tube, exhaust tube from the turbine, and it is get removed with the help of air extraction. It is called a central flow surface condenser. It is having more efficiency than that of the downflow because more area is exposed to the water. Understood? I think is more. Only thing is there that honeytube-like structure is there for tubing through which the water is flowing. Understand? Okay. So inverted type surface condenser in this type of jet condenser. Yes. Tushar Metkari, good Tushar. So inverted type of surface condenser. In this type of jet condenser, steam enters at the bottom of the shell and flows in upward direction. Air extraction pump is placed at the top. The condensate flows down and removed at the bottom. So this is called an inverted type of surface condenser. So in this type jet condenser, steam enters at the bottom. Generally, steam enters from the top, but here in this case, inverted type of condenser, it is entering into the bottom side, okay, and flowing in the upward direction. And air extraction pump terminal, it placed air just steam something exhaust steam. There we have to air extraction pump is placed at the top. The condensate flows down and removed at the bottom where condensate pump is located. म्हणजे याच्यापेक्षा उलटा पंप हा आहे जिथं आपण काय करतो एअर एक्सट्रॅक्शन पंप इथं डाऊनला आहे तर इथं आपण टॉपला सोडायचा आणि स्टीम इज फ्लोइंग याच्या अशी होती तर स्टीम इज फ्लोइंग इन द अपवर्ड डायरेक्शन. So that kind of condenser is called as air inverted type surface condenser. Okay, now this is evaporative type of surface condenser where there is a very less amount of there is less amount of water is available. Okay, there in that case we have to use this particular here evaporative type of surface condenser. And in this case, now up till now the steam was flowing around the tubes, okay, and water was flowing inside the tube. But here is different case. Here what is different here case is there, it is opposite to that. The steam is entering through the tubes. Here in this here steam is inlet, steam is flowing into this particular tube, okay, and steam is flowing inside these particular tubes, okay, grilled tube pipes are there, through this steam is flowing, and here water is sprayed, this cooling water is going to be sprayed inside this particular nozzles. Why nozzles? Because this cooling water will get in smaller droplets, and due to that more area is going to be exposed, and small droplet it will fall on this particular steam pipe, grilled pipes, and the steam will start condensing, and this steam is get condensate is collected from this condensate outlet, and this water is collecting in the collected tank, okay, and again this water is recirculated once again when it get condensed, while coming it is also coming in contact with air, it is get cooled, okay, and this collecting tank cooled water is again sprayed, the cycle get continued, and this cooling water is going to be sprayed from the top, okay. So this is called as evaporative type of condenser. So here whatever the water is get evaporated, it will take the heat from the steam, and some water is get evaporated, and the remaining water is taken from maybe other source. Okay, so here inside the tube steam is flowing. आतापर्यंत कसं होतं ट्यूब मधून वॉटर फ्लो होत होतं, इव्हॅपोरेट टाइप मध्ये काय होते ट्यूब मधून स्टीम फ्लो होते आणि इट इज गेट कूल्ड heat and this cooling water cools that particular steam. So wherever limited amount of water is there, their source is there we have to use limited water, we have to use this evaporative type surface condenser. Generally this condenser is used in dairy plants, cold storage plant, जिथं आपण समजा इथं आपण बळीराजा कोल्ड स्टोरेज जर तुम्ही बघितला कोल्ड स्टोरेजच्या शेजारी जर एखादा कूलिंग टॉवर बघितला असेल, कंडेन्सर टाइप बघितला असेल तर हा इव्हॅपोरेटिव्ह टाइप कंडेन्सर असतो. कोल्ड स्टोरेजच्या शेजारी जर बाहेर असतो हा स्टोरेजच्या तिथं हा दिस इज इव्हॅपोरेटिव्ह टाइप सरफेस कंडेन्सर. लिमिटेड वॉटर जर असेल तर understood. So it is used for the where the limited water is available and evaporate here inside the tubes, grilled tubes, steam is flowing and water sprayed केला तर वरून आणि these droplets it will cool the steam and steam is get taken into the at the outlet condensed outlet. Collecting time the water is collected and it is again reused once again and again. Understood? Please reply. So cold storage, dairy industry, etc. Wherever the condenser, outside condensers we are using, so there we are using, this is a evaporative type of surface condenser, where limited water is available. So draw diagram. So I'll show PPT. Okay. So there is vacuum efficiency is there one of the concept in the condenser topic. So air, in that case, first of all, we have to understand where air is leakage, air sources of air in condenser, because we want vacuum. Therefore, we don't want air inside the condenser, but still air leaks into the condenser. So air leakage from the atmosphere to the joints part internally under a pressure less than atmospheric pressure. With some of the joints are there and welding, we know that welding joints are not 100% air, we can call they are 100%. They are not welded properly. So small holes, porous holes may be remain, and through which that air may enter into that condenser. Because outside air pressure is more than inside pressure. आणि जास्त प्रेशर कडून लो प्रेशर कडून एअर पटकन फ्लो होते, फास्ट फ्लो होते, त्यामुळे लिकेज मधून थोडीफार एअर फ्लो होण्याची शक्यता आहे. That air accompanied with steam, whatever the steam is coming with the help of from the turbine, boiler, turbine, from the boiler, turbine in which it enters dissolved with feed water. Feed water मधून आहे की त्यातलं ऑक्सिजन त्यात एअर मध्ये मिक्स वॉटर मध्ये मिक्स होतो, स्टीम मध्ये मिक्स होतो. While flowing through the turbine, it will get dissolved air and it may enter into the finally condenser. In jet condenser, little quantity of compensated injection of water, cooling water जे आहे आपण त्याच्यामधून पण एअर फ्लो होऊ शकते. These are the sources of air leakage into the condenser. Joints, then with the help of steam, okay, त्यामुळे feed water मधले जी oxygen air आहे, it is get dissolved in the steam, and then jet condenser मध्ये cooling water बद्दल बरोबरची some air. These are the sources of air inside the condenser. आणि त्याच्यामुळे काय होतं तर it will lowers the thermal efficiency, reduces व्हॅक्यूम पाहिजे, त्यामुळे व्हॅक्यूम कमी झाल्यामुळे थर्मल इफिशियन्सी लो होते, प्रेशर वाढतं कंडेन्सर म्हणलं, टेम्परेचर पण सॅच्युरेशन इट इज इन्क्रीजेड अँड इफिशियन्सी लोड, इन्क्रीजेड रिक्वायरमेंट ऑफ कूलिंग वॉटर, थर्मल इफिशियन्सी लो झाल्यामुळे एअर इट विल इन्क्रीज द रिक्वायरमेंट ऑफ कूलिंग वॉटर, रिड्युसेस हीट ट्रान्सफर अँड करोजन, एअर मध्ये झाल्यामुळे थोडं करोजन इज ऑल्सो इन्क्रीज. अँड मेथड्स फॉर ऑप्टेनिंग मॅक्सिमम air pump. We are using air pump to remove the air from the condenser, and steam air ejectors are there. So these are also used to remove the air from the condenser. Okay, so deaerated feed water. So deaerated feed water means what? Already feed water here we have to use so that the air is removed from that. So deaeration process we have to do, and that deaerated feed water we have to use inside the for the boiler or for the cooling condenser. And airtight joints. So joint, whatever the joints are there, welding joints are there, we have to make airtight, completely tight. So with the help of here some packaging materials, etc. So we can here increase the vacuum by remove the air. So air pump is one of the very important priming device. Steam air ejectors are there, so which will remove the air. Deaerated already, water, the oxygen air is removed outside, and that what feed water we have to remove, use for the steam generation, and airtight joints. Okay, and vacuum we can measure, so this is not our case. Now there is one concept is there, it is vacuum efficiency. Okay, so what is vacuum efficiency? So it is defined as ratio of actual vacuum to the maximum. Efficiency is always ratio of what? Less quantity to maximum quantity. So actual vacuum is always less than the maximum or theoretical vacuum. Okay, so less divided by more. So is always a ratio of efficiency. So always actual vacuum is always lesser than the maximum obtainable, or it is going to be theoretical vacuum, you can say. It is called a theoretical vacuum. So vacuum efficiency is defined as ratio of actual vacuum present here to the maximum possible vacuum or obtainable vacuum. It is called as vacuum efficiency. So actual vacuum divided by maximum possible. Maximum possible म्हणजे काय? PB, barometric pressure divided minus here absolute pressure of T, PS. So this is what vacuum efficiency. Actual vacuum is always less because of air present, and maximum without air we have assumed that vacuum efficiency. So this is called as vacuum efficiency, defined as actually vacuum to the maximum possible vacuum. Now condenser efficiency is one of the things there. So it is defined as the ratio of difference between outlet and inlet temperature of cooling water to the difference between the temperature corresponding to vacuum in the condenser at inlet and of cooling water. Okay, or we'll go to this. Okay, so it is not in our syllabus. This is the last article. So this is, let us having this particular condenser, temperature condenser. This is the length of condenser. Let us consider. So let us consider this as a TW1 condenser inlet temperature. कूलिंग वॉटरचं टेम्परेचर संपल्यानंतर जास्त असतात, नंतर ते काय होत जाणार, कमी कमी होत जाणार. TW1 it is increasing, cooling water temperature, sorry, it will get increased. This is TW2, cooling water temperature, cooling water will get heated, okay, and steam temperature is here, it will be phase change असल्यामुळे steamचं temperature remain constant, okay. तर इथं maximum temperature, इथं actual here काय आहे, actual decrease in temperature किती आहे, TW1 TW तो इथं 1 म्हणू आपण, TW1 to TW1 मोठा आहे, TW1 जे actual rise in cooling water temperature, actual drop in cooling water temperature किती आहे, तो TW1 minus TW2 तेवढं टेम्परेचर त्याचं फक्त कूलिंग वॉटरचं डिक्रीज झालेलं आहे. मॅक्झिमम किती होऊ शकतं, TW1 minus T saturation temperature of steam, हा जो रेशो आहे दिस कॉल्ड एज कंडेन्सर एफिशियन्सी. म्हणजे ऍक्च्युअल rise in cooling water temperature to the maximum possible rise in cooling water temperature, that ratio we call it as a condenser efficiency. Okay, so rise in cooling water temperature divided by temperature corresponding to vacuum means here TS and minus inlet, here TS saturation temperature म्हणतो याला, काय म्हणतो आपण, saturation temperature of cooling water corresponding to vacuum pressure, TS minus TW1. म्हणजे TW1 actual rise in actual rise in cooling water temperature divided by maximum possible, हा काय आहे, maximum possible TS, जे एक corresponding saturation temperature हे vacuum pressure ला आहे ते टेम्परेचर, ह्या टेम्परेचर रेशोला आपण काय म्हणतो, condenser efficiency. Rise in temperature of cooling water divided by temperature of corresponding to vacuum TS minus inlet temperature of cooling water. So this is called as what, here condenser efficiency. Okay, so this is condenser efficiency, and here we'll revise once again to next lecture, and this might be we are completing the lecture, sorry. So here, sorry, here TS, a temperature of steam will be more than the cooling water temperature, so therefore this will be a TS line असणार आहे, काय असणार आहे, वर असणार आहे. TS temperature of steam will be definitely more than the cooling water temperature. हे त्यामुळे इथलं काय येणार आहे, TS TS minus TW, maximum possible rise cooling water. Okay, so TW1 TS जास्त असणार आहे, कारण सॅच्युरेशन फेज कन्व्हर्जन, कारण काय टेम्परेचर कॉन्स्टंट राहतं फेज कन्व्हर्जन मध्ये, TS कॉन्स्टंट, TS minus TW1 मॅक्झिमम जेवढा आहे ते TSW1 आणि मॅक्झिमम TW1 here, this will be TW2, this will be TW, so TW1 minus TW2 and TS minus TW1, ह्याला जो डिफरन्स आहे ह्याला आपण काय म्हणतोय, कंडेन्सर एफिशियन्सी. vacuum efficiency, actual vacuum to the maximum possible. Understand? Please reply. We'll revise once again. Write up I will give today. I think maximum 95% of the topic I covered. Understood, sir? Okay. So again, student notes also I will provide. Prerna, reply. And so with this, I think today we'll stop. Abhijit Babar understood. Thank you, Abhijit.